Hello Velociraptors and welcome to my home. I hope that you are excited for today's adventure. We will be taking a trip to Shoal Creek Greenbelt to observe some of the phenomena we've been discussing in this course. The objective of today's adventure is to observe and analyze a natural cross-section to create an account of an area's geologic past. You will then use this information to help support a local family interested in building the area. Make sure to take notes and enjoy the adventure. Let's hit the road.
As we ride, let's explore where we are headed. As you can see, we have a ways to travel to our destination. The Greenbelt begins at Ascension Seton Medical Center, off 38th Street, running all the way to Lady Bird Lake. As part of this excursion, you are going to use this information to help advise a family on home construction. According to the Austin Board of Realtors, the Austin Round Rock Metropolitan Statistical Area, referred to as MSA, has a median home price of around $365,000. That's an increase of about 19.7%, with no signs of decreasing. Therefore, it is likely that this area will continue to be a popular place to live and build or buy a home. However, this area has a past that many should be cautious of. Flash floods are a subset of flooding that are characterized by their unpredictability and damaging impacts. Major flash floods are common in Central Texas due to intense rainfall events and efficient drainage. This is because there is an infinite source of moist air traveling from the Gulf of Mexico, which helps keep the area from being arid, but introduces a complication. This is only intensified by the presence of the Balcones fault zone, which causes increased instability, resulting in more precipitation or rain. If a system moves through slowly, then the region experiences a large rain event, like the Memorial Day storm, sometimes referred to as the 100-year flood. The Austin Statesman put it, "It's hard now to remember a time when weather alerts didn't come directly to our inboxes and sound alert tones on our cell phones. But on Memorial Day 1981, when 11 inches of rain fell in 3 hours in some places of Austin, there were no personalized, digitalized warnings. Shoal Creek, which normally flows at 90 gallons a minute, was rating at 6.55 million gallons per minute. By morning, 13 people were dead and an untold number were saved by police officers, firefighters, and other public servants. Hundreds of homes were destroyed and Shoal Creek was clogged with dozens of new cars that had washed into the creek from a nearby dealership. The flood was classified as a 100-year flood, so intense that it has only a 1% chance of occurring in a given year. Austin sits in what is known in meteorological circles as Flash Flood Alley, an area of Central Texas prone to extremely heavy rains and flash flooding. When the rain started falling on the Sunday before Memorial Day 1981, it came hard and fast, quickly flooding Shoal Creek, Walnut, Little Walnut, Bee, and Waller Creeks. The destruction was caused in part by real estate development in northwest Austin, which intensified runoff in urban creeks. Austin voters soon approved $12 million for flood mitigation projects, and in 1982, the city opened its Emergency Operations Center, which focused on helping first responders prepare for future floods. After the 1981 flood, the city also teamed up with the U.S. Geologic Survey to start a flood early warning system that monitors 120 stream flow and rain gauges throughout the city.
Looks like we're here. Let's go take a look. Welcome to the Shoal Creek Greenbelt. As you can see, it is a beautiful day to be outside. The area that we are in is considered the valley. As you can see on the topographic map, it is much lower than the area on the other side of the creek. It is important we note key characteristics that will help us in creating a plan for the local family we're advising. First, let's take a look at the sidewalk running through the valley. What's wrong with it? That's right, it's cracked and has vegetation growing through it in some parts. This is important to remember as advisors. Let's head to the water to investigate further. This is Shoal Creek. Currently, we are standing in the creek bed. We can see that the sediments here are much lighter in color compared to the sediments in the valley. This is what we are referencing in our lesson on aerial photography. These light areas of the creek create the depth that you see for rivers and streams on an aerial photograph, since we have areas of light and areas of dark. We are standing on a common river deposit, which we have already introduced in this course. Do you remember what it is? Alluvium. Hopefully you recall that from our investigation of Austin geology, alluvium is from the Quaternary period, or the Cenozoic era, deposited via rivers and streams. If we take a closer look, most of the alluvium deposits are smooth river stones. They take on this smooth characteristic because the river stone is being beaten up by all the rocks and rubbing against all the rocks and other stones along the way. If we look closely, we can also see some fossils. These little fossils or shells are from an extinct warm water oyster known as Exogyra aretina from the Cretaceous period, approximately 65 to 146 million years ago. We know from the short history on the way here that this area is prone to flooding. However, what evidence do you see around us to support this conclusion? If we look along the sides of the creek, we can see that the vegetation is leaning in this direction. This is evidence of the direction of the flow of the river, and that the river has reached these higher heights on the bank at some point. We can see that we are currently standing in a bend in the river. The deposition of sediment corroborates this conclusion. As water rushes around the bend, the acceleration vector points inward, which is why a majority of the sediments are right along this ridge. We refer to this as a point bar, and where we find most sediments inside of a bend. In addition, we also see several pieces of debris high up on the banks, which were most likely deposited via a flooding event. We know from the Austin American Statesman article that we read on the way here that normally this creek flows at 90 gallons per minute, but during that flooding period had increased to a raging 6.5 million gallons per minute during the Memorial Day flood of 1981. Think about how much water that is rushing through this area, ripping up vegetation and bringing devastation to the area. If you look to your right, you're going to see this natural cross section. This is what we're going to be investigating on this trip and what you're going to be modeling as part of this project. Let's cross the creek and see what's on the other side. If we look at our feet, we notice that the sediment has changed. It no longer has that same characteristic as alluvium. It's much softer. It looks similar to what we might refer to as topsoil. It crumbles relatively easily. Any ideas what it might be? This is Del Rio Clay. Clay, sometimes referred to as shale, has a unique structure. It appears in layers that are tightly packed when they're dry. When it comes into contact with water, the water molecules surround the clay particles, separating the layers, resulting in the expansion of that clay. This results in what we call heave, where the land below a structure, so the land below this rock, heaves upward due to that expansion. However, as the water recedes, the clay begins to dry and the clay particles and layers become closer together, resulting in the shrinkage of the clay. This results in what we call subsidence, where the land below a structure moves downward due to the shrinkage. As clay moves through these cycles of subsidence and heave, it creates complications for the structures it supports. Now, if we look around us, what pieces of evidence do we see that supports this conclusion that the clay is undergoing expansion and shrinkage? You might say that it's the presence of stones like these, kind of scattered throughout. However, this is not evidence of changing clay, but flooding. As the water level rises from where we came, it deposits river stones up here higher on the bank. So not quite the answer. But what about these big boulders that you see throughout here? Why might this be evidence of expanding and shrinking clay? To find out, let's travel higher up to the bank and see what's going on. Once again, the sediments have changed. We are still standing on Del Rio Clay, but the layer right in front of me is much different. It appears very hard and does not appear to be easily broken up like the clay that we saw previously. What do you think it is? You might want to immediately guess that this is limestone, because we've been talking about it in class and several examples of it. However, it could actually be limestone or dolomite. Both are very similar and you can't distinguish them with the naked eye. Limestone is composed of calcium carbonate, CaCO3. Dolomite is the same composition but adds magnesium to the mix. This is important because it changes the way they react with acid. Limestone readily reacts with acid, whereas dolomite does not. To test the rock, I have with me a bottle of dilute acid. Let's see what type it is. That was definitely a violent reaction. Thus, this is limestone, more specifically Buda limestone. If we try to follow this layer from right to left, we see an inconsistency. Looking down the left-hand side, we see that the layer of Buddha limestone goes all the way down to Shoal Creek. But the side that we're standing on right here is relatively thin. And underneath us is Del Rio Clay. What happened? To find out, we need to take a closer look where the point of change happened. Again, here we see a different sediment. So if we look up here, we see the sediment is relatively orangish. This doesn't appear to be any of the sediments that we've come into contact so far. What is it? If I take a sample of the powdered rock and react it with acid, I see that same violent reaction that we observed with limestone. Could this be limestone? Why is it a powder? Take a moment to think. What has occurred at this location? Hopefully you are on the right track. This is a fault line, particularly the Balcones fault line. The orangish sediment here, definitely limestone, has become pulverized. Remember that the Balcones fault is a dip-slip fault, meaning that one side has shifted up and one side has shifted down. That is why there's Del Rio Clay underneath our feet. It was exposed when this side was shifted upward roughly 15 million years ago. Where the two sides meet, or land masses meet, that limestone has been pulverized due to that rubbing and force created when they two rub against each other. Now remember, this didn't happen overnight, this happened over a long period of time. However, you might ask, why are the sides at the top at equal height from left to right? This is because the right-hand side here, as it's been shifted up, it's constantly exposed to erosion, which erodes the top side down so that it matches the left-hand side. But what about those boulders we talked about down there below? What's created them? This was not something that happened during the fault, but because of the fault. Since this right-hand side has been shifted up, this Del Rio Clay down here is now being exposed to water, which means that now it's being exposed to expansion and shrinkage, which means that this limestone right here is exposed to heave and subsidence. Over time, this limestone becomes cracked, like you can see here, and eventually breaks off, rolling down to the bottom. Crazy, right? All of this information is helping you construct a geologic history of this location and provide some crucial advice for your local family. Awesome work, Velociraptors. I hope you enjoyed this virtual excursion of Shoal Creek. We explored the valley for signs of instability and climbed the bank in search for the truth. Good luck on your demonstration of understanding, and thanks for tuning in.